Alright, so hello everyone. Sorry it took me some time to upload this final part of your redox reaction. Okay, so I believe that this is the part where a lot of students will actually struggle in terms of when they ask you to what you call arrange the metals in ascending order, in descending order in terms of their reactivity. Alright, the reactivity series of your metal. This is where a lot of students will struggle. Alright, so I'm going to try my best to what you call simplify it. I try to make it as concise as possible, but at the same time, it will be enough for you to know how to solve your questions, all right, or to understand what is going on here. Okay, so basically about reactivity series of metals, the most common questions that they will ask you to arrange the metals. All right, so before you can go for your exam, you actually need to remember your reactivity series here. All right, this one. So I'm sure your teachers in your schools, right, they will teach you a lot of what they call acronyms, right, on how to memorize these things. Okay, so that is depending on your teacher on how they teach you to memorize, right? But you need to memorize the series first, right? Before you go for your what they call or you sit for your exam. It's important that you know, all right? Okay, so in this part, right, we are actually looking at three different types of reactions. Okay, one is the metal and oxygen, another one is with the carbon, and the final one is with the hydrogen. All right, so I'm going to go straight into the first type of reactivity, which is between metal and oxygen. So you need to know what is going on here. All right, so this is the experimental setup. You need to know how to draw the experimental setup for your essays and also for your paper 3. All right, so this is the experimental setup between the reaction of metal and oxygen. All right, this part here. Okay, so basically what they will always do is like this. They will what they call tell you that this is an experiment, and then they will give you the unknown metal PQR, and then you will see your question will ask you to arrange the reactivity of metals based on the observation. All right, so this is the most common question. Okay, so first let us look at the equation right here. All right, you need to know what is going on. Okay, so when a metal reacts with an oxygen, you form metal oxide. Okay, don't forget. Okay, why I need you to know that you are forming metal oxide is because for different metal oxides, the colors are different. Okay, because once you what they call arrange the metals, they will ask you to suggest the name of the metal, and to know the name of the metal, you actually need to know the color of the metal oxides. All right, okay, so let's first start off with the arrangement. How can I arrange? Now, for reaction of metal and oxygen, this is the easiest to identify. Okay, so if you look at the question here, right, investigate the reactivity of metal PQR towards oxygen. Okay, and then they give you the oxidizing agent. Now you need to know that the potassium manganate here, the function is to supply oxygen. Okay, because they are oxidizing agent, right? Okay, supply oxygen. Since we say that we want the metal to react with oxygen, I need someone to give me the oxygen. So it's the potassium manganate 7 here, or sometimes we can change the oxidizing agent that they use to another type. Right? Just remember that it's to supply oxygen. So the oxygen will flow through the glass wool, and then the metal will react with the oxygen to form the metal oxide. Okay, so how can I arrange? Okay, first thing they will always ask me to do, arrange the reactivity in, let's say, what they call descending order. All right, descending order, meaning I need to arrange the metals so that it's from more electropositive to less electropositive, meaning from higher to lower. All right, but in this case, they give me unknown. So in order to identify or to arrange, okay, I need to look at the observation. Very important here. All right, we always refer to the observation. Okay, so the reaction for metal and oxygen, how can I know whether this fella is on top or bottom of the reactivity series? Is very simple. We straight away look at the reaction here. So if you see this, right, we have burn, and then we have glow very brightly, and then glows faintly. This immediately tells me the reactivity of the metal straight away. So this is very reactive, right? Because we are saying burn. Burn is more reactive, right? So meaning this is on top of the series. Now, after burn is what? We have two glows here, right? But this one is glows very bright. This is faint, meaning that this one is more reactive than Q. Alright, so if I were to arrange it in descending order, meaning from more electropositive to less, P is the most reactive, followed by R, followed by Q, just by looking at the observation here. Okay, so you need to look at the keywords burn, glow. Alright, of course, burn is more reactive. So in descending order, right, so it will P first, R, and then Q. Okay, so meaning that P is more electropositive, Q is less electropositive. That is how you arrange. Alright, so for metal and oxygen is the easiest if I want to arrange. You just look at your observation here. Alright, you see which one is more reactive. The one that is more reactive, alright, burns is on top. Glow is always at the bottom one. Okay, because they are less reactive. Alright, so first part done. Arrange in descending order. Alright, now second part is they will always ask you to suggest, let's say a name, suggest a metal, alright, for P, Q, and R. Okay, here we cannot simply give the name of the metal. I know that here we have a lot of metals, right? And then you just simply put one in, cannot. Alright, we need to know accurately exactly. So to know is which metal, we need to look at the second observation here. Alright, first things first, residue. You see here, residue. Alright, this one is referring to the metal oxide. Okay, so you need to know that the residue is referring to metal oxide. Alright, so in Form 4, Chapter 8, I believe, your salt chapter, right, we learn about the colors of different metal oxides. Okay, so you need to know the colors. You need to memorize. I'm so sorry, there's no other way for you to do this besides memorizing the colors of the metal oxide. Alright, but some are very obvious one. For example, this one, yellow when hot, white when cold. This is for zinc oxide. Okay, so for metal P is zinc. Alright, the residue here that you are forming is zinc oxide, ZNO. Okay, so your metal P here is zinc. Okay, next, residue is black. Okay, this is also very obvious. When residue is black, there's only one metal oxide whereby the residue is black. That is your copper oxide. Okay, so for Q, your metal is copper. Alright, and then finally, let's look at the last one. Alright, residue is brown. Okay, so when the residue is brown, alright, what they call one of the colors of the oxide where the residue is brown is your iron oxide, your iron 3 oxide. Okay, so we can say that this one brown, oops, this is a different color, right, brown, alright, so this we can take your iron 3 oxide, meaning your Fe2O3. So meaning your R is Fe. Okay, so this is the first part of your reactivity series, the reaction between metal and oxygen. So to identify the what they call arrangement of the reactivity series, okay, who is higher, who is lower, we look at the front part observation here, burn, glow, whatever. Alright, so the reactive one will be on top. Okay, the less reactive one will be at the bottom. Okay, and then if I want to know is which metal, I need to look at the residue here, the one at the back. Right, so you need to know the color of the metal oxides. Then only we can identify the metal here. Okay, so that is the first one. Right, done. Alright, so the second type of reactivity series, right, will be about your metal oxide and also your carbon. Alright, so this is the part where quite a number of questions will be asked, especially about the position of carbon, and the next one will be about the position of hydrogen in the reactivity series here. Alright, so first things first, you need to understand what is going on is that when you react the carbon and the metal oxide, what do you get? Okay, so I've written the general equation here, right? Is that when the carbon reacts with the metal oxide, you are going to get the metal and the carbon dioxide. So basically what is happening here is that the carbon is going to replace the metal and take the oxygen. Alright, but whether the carbon can do this, meaning whether the carbon can replace the metal or not, depends on the position of the carbon. So you need to remember the concept whereby the one higher can displace the one lower. Okay, meaning that carbon, okay, if you look at my position of carbon in the reactivity series here, right? Okay, carbon can displace. Alright, oops, my writing. Okay, displace, D-I-S-P-L-E-S. Let me just write back lah. Right, displace. Okay, displace. Okay, the meaning of displace meaning replace lah, we substitute lah. Alright, but in your exam you need to write this word lah. This is your keyword. Okay, so just remember the concept. Only when the carbon is higher than the metal that the reaction can happen. So let's say if I give you two different equations, right? One is with magnesium oxide. Another one is with, let's say, copper oxide. Alright, so if given these two different reaction, okay, first we look at the carbon and the magnesium. Okay, remember, it is always the carbon that is going to go and steal the oxygen. Alright, so whether the carbon can steal the oxygen depends on where the magnesium is. Since magnesium is higher than carbon, right? Meaning magnesium is more hebat lah, meaning carbon cannot replace magnesium, so no reaction will happen. Now next, carbon and copper. Copper is lower than carbon, right, in the reactivity series. So meaning that carbon can go and steal the oxygen. So they kick the copper out. So copper will be kicked out. Alright. And then you're going to get your carbon dioxide. Okay, so basically this is what is going on when you react a carbon with the metal oxide. Okay, you need to identify whether the reaction can happen or not. This one will depend on the position of the carbon. If higher, only reaction will happen. If carbon is lower, then no reaction will happen. Okay, so in your exam, what they will do is that they will give you the unknown metals again. They always give you PQR, WXY, whatever lah. Okay, so based on this one, they will ask you to arrange the position of the three metals and carbon. Alright, in terms of the reactivity. Okay, so if they were to ask you to arrange, let's say in the ascending order lah, right? Ascending order meaning from less electropositive to more electropositive, meaning from low to high. Okay, so we need to identify whether the metals are higher or lower than carbon. Okay, we need to know where carbon is. Alright, so let's look at the first observation here, experiment 1. Okay, carbon and P oxide, no change. Okay, meaning no reaction happening. No reaction happening is same as this one, right? Meaning that carbon is lower than P. So you always remember this one. No change, meaning carbon lower than P. Okay, so I already know that P is higher than carbon. Alright, now next, let's look at 2 and 3. So 2 and 3, we have observations, right? Okay, so if you have observations, okay, meaning that this one, that carbon is higher than Q and R. Alright, so got observation, carbon is higher. No observation, carbon is lower than the metal. Okay, so very simple concept. Alright, now the problem is with Q and R. I need to know who is higher than who. Alright, so to know this, we look at the observation in front here. Okay, so we are going to apply almost the same concept that we use for your oxygen. Alright, just that slightly different. Okay, this is bright, this is dim, right? So this one is more reactive, right? So for the arrangement for carbon and metal oxide, let me share with you how I do this. Bright, meaning that R is further from carbon. If you are reactive, meaning you are further away from the carbon. If you are less reactive, meaning you are nearer to the carbon. Okay, so based on this observation, bright, right, I know that R is further away from carbon compared to Q. So if I were to arrange in ascending order, meaning the less reactive one, it will be R, followed by Q, followed by carbon, finally P. So this one we are going in ascending order, right? Ascending order. Less electropositive to more electropositive. Okay, so that is how we identify. It's based on this one. So I repeat again. If reactive, meaning the metal is further from carbon. Less reactive, meaning the metal is nearer to the carbon. Right? That is how we are able to identify the position of the we call elements here. Okay, the metal and the carbon. Alright, now next question. As you know, they will ask you to suggest a name for P, Q, and R. Okay, so since I know that carbon is lower than P, meaning it is any of the metals which is higher than the carbon right here. Alright, so P, you can put, doesn't matter like aluminium or magnesium also can, I think. Alright, okay, now for Q and R. Okay, for Q and R, it will depend on the observation at the back here. Okay, the color of the metal. So you need to remember the colors of the metal. Alright, now this is dim glow, right? So I know that the metal are nearer to carbon. So it will either be iron or maybe tin or lead. Alright, because dim. If zinc, right, this one will be very dim. Okay, so you need to roughly know how we identify is who. Okay, gray solid here, meaning that it can either be iron or lead, because these two colors are gray in color. Alright, zinc is also gray in color, but why I do not write zinc is because if the Q is zinc, right, this observation here, it should be very dim, okay, or maybe faint glow, something like that. Okay, now for R, okay, this one I believe everyone knows, right? Brown solid only got one, which is copper. Okay, so that is how we identify. Alright, so for arrangement, okay, arrangement, we look at the front observation here, the what we call reactivity here, got burn or bright or dim. Then we know how to arrange the what we call elements. For colors of the metal, which is your residue here, okay, your residue is referring to this one, your metal. Right, you need to remember the colors of the metal. Okay, then only you are able to suggest the what we call name of the metal. Alright, so that is how we identify the we call reactivity series for the reaction between carbon and metal oxide. Okay, so this is the experimental setup. Okay, remember you need to know this for your what they call paper 2 and paper 3 lah. Alright, so normally when I teach my students, right, I always ask them to identify the setup. If I see a setup like this, I know that this is between carbon and metal oxide. Alright, if I were to see this setup, okay, then I know that this one is between metal and oxygen. Okay, so it's something like that. Alright, so that is how you do it for metal oxide and carbon. Okay, so if you can understand how we identify or how we arrange the metals for the carbon in reactivity series, right, then you will be able to do it for your hydrogen. Same exactly, it's exactly the same method. Okay, alright, we see whether the hydrogen can displace the metal. For hydrogen, it's better. Why? Because hydrogen can only displace 4 metals only. If you look here, right? Let me remove this first. Okay, below hydrogen only you got 4 metals. Iron, tin, lead, and copper only. Alright, so other than that, the hydrogen cannot replace one. Alright, so this is the reaction. Okay, when you take the hydrogen, react with the metal oxide, you will get the metal and the water. Remember, you are forming water here. Okay, so again, let me give you an example. Let's say now you go multiply. Okay, plus let's say magnesium oxide. And then another one is, let's say, use back the same thing lah. Okay, so it's very simple. Magnesium is higher than the hydrogen, right? So meaning your hydrogen cannot steal the oxygen, so no reaction happens here. So this one you compare this and this. Remember, it is always the single element that go and steal other people's one. So hydrogen can displace copper, so copper will be kicked out. So you kick the copper out, and then you take this hydrogen, this oxygen. You steal this oxygen lah. Oh no, not carbon. Oh my god, there's water. Okay. Then the reaction will happen. Okay, so it's the same concept. If the hydrogen is higher than the metal, then reaction will happen. All right. If the metal is higher than the hydrogen, then no reaction will happen. Okay. So let's look at the observation here. All right. So determine the position of hydrogen in the reactivity series of metal. So let's look at one by one. All right. Again, we are going to arrange the what we call metals. Okay, so we are going to go for ascending order. Okay, let's see. Okay, who is higher than who? Alright, X, Y, Z. Okay, first things first. In order for me to know, first thing you always identify is you try and see whether the observation tells you whether there is a reaction or no reaction. Okay, so if it's no reaction, so I'm going to teach you how to do this. Oxide of X is black powder, meaning that this one, before reaction is black. After reaction, it becomes brown, meaning that this reaction is happening because the color changed already, right? So meaning that your reaction happens. If reaction happens, means that your hydrogen is higher than the metal. Okay, let's look at the second one. All right, before, meaning oxide is white. After hydrogen reacts, but it's still white. Okay, no changes in the color, right? Meaning this is no reaction. No reaction. Okay, if no reaction, meaning that my Y is higher than the hydrogen. Okay, so that is how we identify. Alright, last one, let's check again. Before is yellow. Okay, oxide of Z is yellow powder. After react with hydrogen, it changes into gray, meaning residue is gray, right? So this one means you have reaction because color different. So meaning that hydrogen is higher than Z. Alright, so now I already roughly know that Y is higher than the hydrogen. Hydrogen is higher than X and Z. Okay, so who is higher than who? Again, we are going to use the same thing. This is bright glow. This is faint glow. So remember, if it's reactive, meaning that the metal is further from the hydrogen. Right? Less reactive, meaning it's nearer to the hydrogen. So in this case, meaning that ascending order, the least reactive one will be what they call X here. Alright, because X is further from the hydrogen, so I'm going to put it in vertical, easier for you to see. So X, after X is Z, and then hydrogen, and then Y. Okay, so I check back again. Okay, bright glow, meaning the X should be further than hydrogen. So X is further than hydrogen. Okay, correct. Faint glow, meaning the Z should be nearer to hydrogen. So this is nearer to hydrogen. So this is also correct. Alright, so that is how we identify, okay, how to arrange it in ascending order or descending order depending on the question. Alright, okay, so first part done. Okay, then they will ask you to suggest the metal X, Y, and Z is what metal. So again, you need to know the color of the what they call metal that you are forming. Okay, so as you can see here, residue is brown powder. Alright, so remember your residue is referring to the metal, meaning this one. Okay, so brown powder, so meaning X is copper. Alright, so this one. Okay, now for Y, right, they give you another specific information, which is this one. Yellow when heated Alright, so if it's yellow when heated, I already know there's only one metal that has this color, which is your zinc. Okay, so let's check whether my answer is correct. Alright, I say Y is zinc. Okay, meaning that because I already know that Y is higher than hydrogen, right? So let's see whether zinc is higher than hydrogen. So correct, zinc is higher than hydrogen. Okay, so meaning this one is really correct lah, betul. Okay, so for Z, so the color given here is yellow powder. Okay, all right, let me just remove this. Okay, I forgot to mention this. All right, okay, yellow powder. Oxide Z is yellow powder. All right, and then the residue is gray. Now there is only one, not to say only one but the one that you learn, right? Yellow powder oxide is lead oxide. So my Z here is Pb. Okay, lead. Okay, so it's correct. Why? Because lead is lower than hydrogen, so reaction can happen. Okay, so all right, to know arrangement, reactivity, we look at the front observation. Okay, meaning we see whether they have any observation or any reaction is happening. No reaction happening, meaning that the metal is higher than the hydrogen or carbon. All right, if reaction happens, meaning that the metal is lower than the hydrogen or lower than carbon. Okay, and then to know who is higher than who, we look at the reactivity here, bright glow. All right, whether it's burning or burning. Okay, so if it's reactive, bright glow, just remember reactive meaning that metal further from hydrogen or metal further from carbon. Less reactive meaning metal is nearer to the hydrogen or nearer to the carbon, if we are talking about carbon lah. All right, and then to know what metal is it, we look at the observation at the back, the color of the powder. All right, okay, so this one oxide X, meaning X oxide here is black powder. You only have one black powder oxide, which is copper oxide. So I confirm it by looking at the residue, brown. So this one is copper, so this is correct. Okay, oxide Y is white powder, white powder, right? So zinc oxide is white powder. A lot of oxide is white powder, but because they give me this one, yellow when heated, so immediately I know that this is zinc. Okay, and then this one finally yellow powder, right? And then residue is gray. So this is for lead. Okay, so for identification of metals, it depends on whether you can remember the colors of your salts and also colors of your metal, meaning you need to revise back your Form 4 Chapter 8. Then only you can suggest the name of the metal. Then only you know this metal is who. Alright, if not, you won't be able to identify. Okay, so basically that is how we determine the arrangements for reactivity series. Okay, for metal and oxygen, metal oxide and carbon, and metal oxide and hydrogen. All right, now one final thing before I end the video is this. Okay, since we are talking about redox reaction, right? So we need to know oxidation and reduction. Okay, so if I were to take this, let's say this is the reaction, right? Okay, for carbon, so I need to know which one is oxidation, which one is reduction. Okay, so again, we look back at our, this one is very simple. Okay, so now your copper oxide is being reduced to copper, right? This one loses its oxygen, right? So this is reduction. Okay, whereas this one, carbon gains oxygen, right? So this is oxidation. So meaning that carbon is your reducing agent. So I write short form lah, reducing agent. And then your copper oxide here, this is your oxidizing agent. Okay, a bit messy lah, but never mind. Alright, so that is how you identify redox reaction. Okay, same thing goes for this one also. All right, so meaning that your carbon and your hydrogens are your reducing agents. Okay, just remember carbon and hydrogens are reducing agents. All right, so I believe that is it for your reactivity series, how you identify. Okay, so hope this one will help you all in your exams. Okay, hopefully now you know how we arrange, okay, the metals. All right, so that's it for today. Bye bye.